Okay, 55. It says, for the following exercises, use a calculator with CAS to answer the questions. And when I saw that, I must confess that I did a double take. I know what CAS means, Computer Algebra System. I use a primitive one on my computer. It was designed for Windows version 3, Maple. It's actually Scientific Workplace 2.0 with Maple bundled together. Maple is a really powerful CAS, Computer Algebra System. They still make Maple nowadays. It's way past the version I have now. And anyways, I was using it, I think, since I had maybe Windows 95. I don't know. Anyway, it came with like 12 floppy disks to install it, and I was able to use it on Windows 95. It was designed for Windows 3, and I was in fact able to use it with Windows XP. But when Windows 7 came out, which is what I'm using now, it won't work anymore. So I had to get an emulator, a Windows XP emulator, and use it that way so I could continue to use it. Because, you know, the prices for these mathematical CASs are really sky high for people like me. For a student, they're not bad, you know, but I'm long past my student days. And I'm retired, and so I don't have that kind of cash to shell out for a CAS anymore, you know, so I'm on a fixed income, so I have to watch out. I have to be careful. But yeah, I've been out of the loop for a long time, being retired, and so I was kind of shocked to see that you got to be kidding. They have calculators with CASs now. Well, I've had some primitive versions of that on calculators that I've used. Well, before you laugh, let me show you a calculator I used when I was a math student. This one. This is the Casio FX7000G. Alright, this is the world's first graphing calculator. Not this particular one, but of course, but it's the model. This model was the world's first graphing calculator, Casio FX7000G. Alright, so I was using graphing calculators before many of you were born, okay, so don't laugh too hard at me, alright. So yeah, these were great fun to use, especially after having to do graphs by hand before these things came out. And then I used an HP28S, which you've seen before. I've showed on this channel. That was my favorite calculator, but its graphing abilities were not very good. And it has a primitive computer algebra system, but it's not very good. It's very, very slow. You have to wait minutes sometimes for it to simplify something. All right, and then I went to this one. I used this when I taught AP Calculus and had my students use it. The HP48GX. Alright, this was powerful for its time, very powerful. Back in the day, HPs ruled, not TIs. Alright, if you had a TI, that showed you were an amateur. The real pros carried around HPs. They were designed by and for engineers. They were built really ruggedly. These calculators of mine still work, by the way. So you can still get them on eBay, you know. You can relive the past if you're my age. Get your old calculator back again, and you know, every calculator works differently, and it takes a long time to learn these things sometimes, and so I just quit buying calculators after a while, and now I'm mainly using my Maple software to assist me in doing some of these problems, all right, or to check my work. Anyway, let's go ahead and tackle this problem. Huh? 55. You can get your whatever you prefer, your method of CAS, and we will look at this problem. Consider we've got x to the k plus 1 over x plus 1. And we've got k equals 135. So consider that for k equals 135. What do you expect the result to be if k equals 7? So what they're expecting you to do is punch this expression into your CAS system, and then let k go through these values. All right? And they want to see if you can detect some kind of a pattern. So let me write this out. If k equals 1, what you have is x plus 1 over x plus 1. Of course, that's 1. All right? And as long as x doesn't equal -1, of course. All right, then it's undefined. But we're not going to worry about that. Okay, what about k equals 3? So we've got x cubed plus 1 over x plus 1, and that equals, using your CAS, you can simplify that, and you'll get x squared, or you can use synthetic division if you wish, x squared minus x plus 1. And k equals 5. X to the 5th plus 1 over x plus 1. And then you've got that equals x to the 4th minus x cubed plus x squared minus x plus 1. And this is what Maple gave me. I didn't bother with synthetic division. It's so much easier just pushing buttons on a computer, right? Or a CAS system. Alright, now here's what I came up with. For k equals 7, here's what I expect. If you look at this pattern here, alright, you've got 1, negative x, x squared, negative x cubed, x to the 4th. 1, negative x, x squared, 1. Alright, if you start from the right hand side, you'll see the pattern pretty easily. So I expect this to be, when k equals 7, x to the 6th minus x to the 5th. Notice the signs, S-I-G-N, the signs alternate, plus minus. And we've got plus x to the 4th minus x cubed plus x squared minus x plus 1. And with the computer algebra system, this would be very easy to check. So this is a natural problem for a computer to handle, because it eliminates a lot of the hard labor, all right, so to speak, the time-consuming labor. All right. So in fact, this is true. I checked it when k equals 7 using my CAS. All right. So that's what we expect. Now let me go a little step further, which isn't really called for in our book, but I'm going to give you more for your money. All right. You're going to see formulas like this when you get into calculus, so I thought I'd break it to you a little bit gently here. All right. So while it really doesn't matter, but you'll see this later when you take calculus. I'm going to write a formula for this. Here's a general formula. X to the 2n plus 1 plus 1 divided by x plus 1 is equal to the sum. Now I've covered this symbol before, especially when we did a little statistical work. Remember that? With lines, regression lines, lines of best fit, that sort of thing. We went into this symbol that's used quite a bit. This means the sum, as k goes from 0 to 2n of negative x to the k, and n equals 0, 1, 2, and so forth. Alright. Now 2n plus 1, if n equals 0, that would be 1, x to the 1. If n equals 1, that would be 2 times 1 is 2, plus 1 is 3, so x cubed plus 1. See, this will give you all the odd numbers that we're looking for here, the odd numbers. Alright, 2n plus 1. You could also use 2n minus 1 for odd numbers. 2n by itself would give you all the even numbers. If n goes from 0, n is 0, 1, 2, 3, 4, 5. If you write 2n, that'll give you even numbers. Alright? So that fact alone can help you a lot doing more advanced mathematics. Alright? Just remember, 2n plus or minus 1 will give you odd numbers. And for n, natural numbers n. And 2n will give you even numbers. Alright, so this basically represents what we have here. Okay, this part right here. Now this, let me give you a simple example of how this thing works again. We did cover this before, but it bears repeating because you don't see it too often in this course. Okay, here's our, let's say we've got the sum as k goes from 1 to 3 of x to the k. What does that mean? Alright, that means first you let k equal 1 and write x to the 1. And sum means you add. The next term is added, so you put a plus. And now you let k equal 2. Alright, so k goes from 1 to 3. And these are natural numbers. Alright, so x squared plus, and then k equals 3, and that's when you stop, x cubed. So this symbolizes this sum here. Alright, so you follow this. First you start at k equals 0, okay, and you write negative x to the 0, which equals positive 1. Alright, negative x to the 0 will be positive 1, and then write a plus, and now k equals 1. Okay, so now you've got a negative x to the 1, or just negative x. And you keep going until you reach 2n. Alright? So, for example, for k equals 5, 2n plus 1 equals 5. So n is going to be what? 2, right? 2 times 2 is 4, plus 1 is 5. N is going to be 2. So this will go all the way to 2 times 2 is 4. Alright? 0 to 4. Okay? So, you know, you can try this formula with what we've already done up here, okay? And yeah, I know it can get confusing because you've got more than one letter here, more than one, if you want to call it a variable, k and n. So you have to practice with it a little bit to get used to it. Once you get used to it, it's an extremely powerful time saver, a space saver. And you can write your formulas concisely, and you may not enjoy doing it. I mean, you may not like it, especially when you first see it, but you have to get used to it if you plan to go ahead in mathematics, all right? Because you're going to see a lot of this kind of stuff in mathematics. And there's also something for multiplication. This is for addition of each term. For multiplication, you'd use a big pi symbol, like k goes from 0 to 2n and so on, blah blah blah. Alright, so instead of adding each term, you would multiply each term if you use this symbol. Alright, so this one you don't see too often. But anyway, yeah, there's your introduction to a little bit more advanced mathematics, but it's coming up quick when you take calculus. Alright, so there you go. Okay, 57. So we will consider, let's see, x to the k over x plus 1, and k is 1, 2, 3. So what do you expect if k equals 4? Okay, so let's try k equals 1. It's going to be x over x plus 1 is equal to 1 minus 1 over x plus 1. How about k equals 2? That's going to be x squared over x plus 1. That's x minus 1 plus 1 over x plus 1. And 3. K equals 3. Oops. 3. There we go. X cubed over x plus 1. So we've got x squared minus x plus 1, x squared minus x plus 1 minus 1 over x plus 1. So what about k equals 4? Here's what we expect. If you look at the pattern here, it's not as easy as the last one because the signs are not the same as the last ones. They alternate, and so they do alternate, but I mean they don't alternate in the same way that they did in the previous problem. So a general formula for this is going to be harder to come up with. But anyway, they're not asking us for that, are they? So it doesn't matter right now. But let's see what we get for k equals 4. It's x cubed minus x squared plus x minus 1 plus 1 over x plus 1. That's what we expect, and that is indeed the case. Alright, now I wanted to try to come up with a general formula for this, and I had to make it in two formulas depending on what we had going on. So I don't know, maybe there's one formula for this, and maybe one of you can figure it out if there is one. I don't know. I spent a while working on this, and I had to write two formulas. But if you've got the time and the inclination, maybe you can come up with just one formula for this. But remember, it has to work with all cases, right? It has to work, give you the correct result in all cases. So here's my two formulas. If n is even, and n is greater than or equal to 2, here's what we can use. X to the n over x plus 1 is equal to the sum. By the way, that's uppercase Greek letter sigma. Lowercase Greek letter sigma looks kind of like a cursive O, like that. That's used quite a bit in statistics for standard deviation. All right, but in mathematics proper, you won't see this too often. You'll see this quite a bit, the capital sigma. But anyway, it's the sum as k goes from 0 to n minus 1 of, that's a bracket, negative of negative x to the k plus 1 over x plus 1. That's a 1 there. Alright, so this part of it isn't attached to that part. Alright, what this formula is working on is in the brackets there. Alright, so this is, you would write that down separately and then work on this part. Now if n is odd, n is greater than or equal to 1, we have x to the n over x plus 1 is equal to the sum as k goes from 0 to n minus 1 of negative x to the k minus 1 over x plus 1. Alright, so for example, if k equals 3, then which one does it apply to? Okay, k equals 3, so the n here represents that k, see, 3. So n is odd, yeah, and 3 is greater than or equal to 1. Okay, so you would use this formula. And you would start it over here, you'd start at k equals 0, and then you add to that all the way up to 3 minus 1, which is 2. 0, 1, 2. Write that out. Okay? And it'll give you this result right here. Alright? Now if n is even, like if k equals 2, then you would use this formula. And for example, if again k equals 2, you would see that result when you plug it into this formula. Alright? So there you go. Number 59. For the following exercises, use synthetic division to determine the quotient involving a complex number. So we have x plus 1 over x minus I. So you treat I as we've been treating the k and x minus k. So you just put the I in the upper left corner. Write the coefficients of the dividend, 1x and 1. Drop the 1 down. I times 1 is I. And so we write it over here. I plus 1 is I plus 1, or 1 plus I as it's conventionally written. Remember, the format for a complex number is a plus bi, where a and b are real numbers. So there's your a plus bi. b is 1 here. Okay, so well, that's all there is to this. So x plus 1 divided by x minus I is equal to 1 plus the remainder, 1 plus I, over the divisor, which is x minus I. And that's that. (61) x plus 1 over x plus I, or x minus a negative I. So you write the negative I up here. Write your coefficients of the dividend. Drop down the 1. And you've got negative I times 1 is negative I. And so add those two, that's 1 minus I. And we're done there. So x plus 1 over x plus I is equal to 1 plus the remainder over the divisor. Like that. 63. We have x cubed plus 1 divided by x minus I. Alright, so we put our I up there in the corner and write our coefficients. So you got a 1x cubed, a 0x squared, a 0x, and a 1. Constant term. Drop down the 1. I times 1 is I. I plus 0 is I. I times I, that's I squared, which of course is negative 1. 0 minus 1 is minus 1. And then I times negative 1 is negative I. 1 plus a negative I is 1 minus I. Okay, so that takes care of that one. So we've got x cubed plus 1 divided by x minus I is equal to, since we started with an x cubed in the dividend, this is an x squared, 1x squared. So you've got x squared plus ix. Remember, these are the coefficients, so you put the I there like a coefficient. Ix minus 1 plus the remainder over the divisor. 1 minus I over x minus I. (65) For the following exercise, use the given length and area of a rectangle to express the width algebraically. So they're saying algebraically, in other words, you're going to get an expression involving a variable. We're using x's here, so you'll get an expression involving a variable x instead of just a number, which is what we're used to using when we find widths, lengths, that sort of thing. All right. So the length is given algebraically as 2x plus 5. And the area (4 x cubed plus 10x squared plus 6x plus 15. Okay. So length times width equals the area of a rectangle. So if you divide the area by the length, that should give us the width. Okay, so I'm going to use just long division here, since in my opinion we need a little more practice in long division. Synthetic division would work here, but we'd have to massage this divisor a little bit to get that leading coefficient to be a 1, and so, you know, I don't want to mess with that, so I'll just use long division. And so we divide the length into the area, 4x cubed plus 10x squared plus 6x plus 15. And don't worry, even though we're talking about area of a rectangle, which should be in square units, they're giving cubes here, but don't worry about that. Just do the division. And we take the leading coefficient, or the leading term, 2x, divided into 4x cubed. 4x cubed, in other words, divided by 2x is equal to 2x squared. All right. So that is what you write here. And then you go 2x squared times 2x is 4x cubed. Again, you should always get the leading term, the first term, leading term, when you do that first multiplication. 2x squared times 2x is 4x cubed. And then 2x squared times 5 is 10x squared. put that under its like term in the dividend, 10x squared. And then you subtract all of that from the like terms in the dividend. So you got 4x cubed minus 4x cubed is 0. 10x squared minus 10x squared is 0. Alright, now you just drop down the 6x plus 15. And then you divide 2x into 6x, or 6x divided by 2x equals 3. This into that. Alright, so you get 3. Alright. Now you go 3 times 2x is 6x, and 3 times 5 is 15. That's plus 15, or positive 15. Subtract all of that and you can see the result is going to be 0. The remainder is 0. So the width is the quotient 2x squared plus 3. (67) For the following exercises, use the given volume of a box and its length and width to express the height of the box algebraically. So if you remember, the volume has 3 dimensions. That's a 3-dimensional measurement, and we're given the volume and also length and width, so we're looking for the depth or the height here, the height as they say. And so if you multiply length times width and divide the volume by length times width, we should get what we're looking for, the height. So the volume, I'll just call it V, is 12x cubed plus 20x squared minus 21x minus 36. And the length, I'll call it L, is 2x plus 3. And the width, call it W, is 3x minus 4. We're looking for height H. So let's go length times width first. Length times width is equal to 2x plus 3 times 3x minus 4. Alright, if you do that multiplication, you get 6x squared plus x minus 12. Alright, so we use that as our divisor. Now, this is an x squared term. You can't use that in synthetic division. You have to have a linear divisor, in other words, a degree 1 divisor. And so you cannot use synthetic division with this problem, even if you wanted to. Alright? So we use long division. So we write it out, 6x squared plus x minus 12 into the volume, 12x cubed plus 20x squared minus 21x minus 36. Alright, so you take 12x cubed, divide that by 6x squared. I'll write it up here. 12x cubed divided by 6x squared is equal to 2x. So you write that right there. And then you multiply. 2x times 6x squared is 12x cubed. 2x times x is 2x squared. Write that under its like term in the dividend. 2x squared. And then 2x times negative 12 is negative 24x, write that under its like term, minus, that's a negative 24x. And then draw your line, subtract all of that from its from the like terms in the dividend. Okay, so you got 12x cubed minus 12x cubed is 0. 20x squared minus a 2x squared is 18x squared. And then minus a minus here is a plus, so this is going to be 24x minus 21x. Positive 24x minus 21x is 3x plus 3x. Bring down the minus 36. Alright, now you go 18x squared divided by 6x squared. 18x squared divided by 6x squared is 3. Alright, so you've got plus 3 up here. And then 3 times 6x squared is 18x squared. 3 times x is 3x, positive 3x. And 3 times negative 12 is minus 36. And then you subtract all that, but I think you see what happens. You're going to get a 0 remainder. Alright? So I'll leave the rest of that to you there. And so this is our height. The height is 2x plus 3 in the quotient there. Okay, number 69. So the volume V is 10x cubed plus 27x squared plus 2x minus 24. The length L, 5x minus 4. The width W is 2x plus 3. So again, you could do this like the previous problem, multiply length times width, and then use the result to divide into the volume. Or, here's another way to do it, I thought I'd try. We can divide the volume by either the length or the width, and the result is going to be a quadratic, a degree 2 polynomial. Okay? And then what we can do is factor that polynomial, and we'll see right away what the length or the height would be. So let's try that. So I think I'll use 2x plus 3 as the divisor. You could use either one of these. Alright, so I'll just use the width 2x plus 3. If you want to make it more interesting, use the width and basically use a similar method to get the height. So you've got 10x cubed plus 27x squared plus 2x minus 24. Okay, so 10x cubed divided by 2x is 5x squared. And then 5x squared times 2x is 10x cubed. 5x squared times 3 is 15x squared. And we subtract. That leaves us with 27x squared minus 15x squared is 12x squared. And then bring down the 2x up here, plus 2x. 2x into 12x squared, or 12x squared divided by 2x, is 6x. 6x times 2x is 12x squared. 6x times 3 is 18x. And then you subtract that. So 2x minus 18x is negative 16x. Bring down the negative 24. Okay, so you go negative 16x divided by 2x, that's a negative 8. Negative 8 times 2x is negative 16x. Negative 8 times 3 is negative 24, and you can see the remainder will be 0. Alright, so now we factor 5x squared plus 6x minus 8, that's our quotient, and that turns out to be x plus 2 times 5x minus 4. And as you can see, the 5x minus 4 is the length, so that must be the height, x plus 2. H equals x plus 2. So if you're not in the mood to multiply these two out first and then do the division, if you insist on using synthetic division, you could use this method. Of course, you still have to manipulate this divisor to get the leading coefficient to be a 1 when you use synthetic division. We've done that in some of the previous problems. So, you know, I don't know which is more trouble. It seems about the same amount of trouble, but there you go. Okay, number 71, the penultimate problem. Don't you just love to hear that? It's almost as good as the ultimate problem. So, here we go. For the following exercises, use the given volume and radius of a cylinder to express the height of the cylinder algebraically. Okay, so the volume of a cylinder is pi r squared h. Remember that. Pi times the radius squared times the height h. Alright, so the volume here, we expect to see pi in there somewhere, and we do. Pi times the quantity 25x cubed minus 65x squared minus 29x minus 3. Radius, call it r, is 5x plus 1. Okay, so again the volume is equal to pi r squared h, where r is the radius and h is the height of the cylinder. So we need to find h. So you divide both sides of this formula by h. So you get h is equal to v divided by pi r squared. Now what's r squared? Well, we have to do that. We have to figure that out. R squared, let me write it over here because I'm running out of space. R squared is equal to the quantity 5x plus 1 squared. And that equals 25x squared. Remember, a plus b quantity squared, a squared plus 2ab plus b squared. Alright, so that's 25x squared plus 10x plus 1. Okay, so there we go. We need to divide the volume by pi r squared. Alright. So, what's the volume? The volume has pi and then this polynomial. And pi r squared also has pi times this polynomial. So when you put volume divided by pi r squared, the pi's will cancel out. Correct? Yes, that is correct. So you can check me on that if you want. So all you have to do in the long division is just divide this polynomial by that one. You can forget about the pi's because they were canceled out. Okay, so we've got 25x squared plus 10x plus 1. And that goes into the volume, part of the volume without the pi. 25x cubed minus 65x squared minus 29x minus 3. Okay, so 25x cubed divided by 25x squared is just plain old x. And then x times 25x squared is 25x cubed. X times 10x is 10x squared. X times 1 is x. That's just plus x. Subtract all of that. And so you end up with a negative 65x squared minus a 10x squared is minus 75x squared. Negative 29x minus another x is negative 30x. And drop down the minus 3. Then you go negative 75x squared divided by 25x squared is negative 3. So negative 3 times 25x squared is negative 75x squared. Negative 3 times 10x is negative 30x. Negative 3 times 1 is negative 3. You subtract that and you can see you're going to get a 0 remainder. So therefore, h is the quotient here. Therefore, h equals x minus 3. Okay, the last problem in this section. The journey of 1,000 miles begins with a single step. We've taken more than a single step. So here we are. Volume is pi times the quantity 3x to the 4th plus 24x cubed plus 46x squared minus 16x minus 32. Now again, the volume of a cylinder with radius r and height h is v equals pi r squared h. It's got a circular base, so the area of that circular base is pi r squared, of course. That's the area of a circle times the height. Okay, so h, just divide both sides by pi r squared. H is v divided by pi r squared, just like in the previous problem. Okay, r squared r was given as x plus 4. I forgot to write that down, but r squared then is x plus 4 quantity squared. And a plus b squared is a squared plus 2ab plus b squared, right? So we've got x squared plus 8x plus 16. Okay, so the height is the volume divided by the area of the base and of the cylinder, and pi r squared is going to have a pi times this polynomial. So you're going to divide pi times this polynomial over pi times that polynomial. The pi's will cancel out. Alright, so all you have to divide is this polynomial by that polynomial, and that is good enough because the pi's are canceled out when you do that division. So you've got x squared plus 8x plus 16 into 3x to the 4th plus 24x cubed plus 46x squared minus 16x minus 32. 3x to the fourth divided by x squared is 3x squared, right? 3x to the fourth divided by x squared is 3x squared. Okay? So that's what you write up here, 3x squared. 3x squared times x squared is 3x to the fourth. 3x squared times 8x is 24x cubed. And 3x squared times 16 is 48x squared. Oh, that was so close. This was almost a super easy subtraction here. So 46x squared minus 48x squared is negative 2x squared. It's still pretty easy. And then bring down the minus 16x minus 32. Negative 2x squared divided by x squared is negative 2. So negative 2 times x squared is negative 2x squared. Negative 2 times 8x is negative 16x. Negative 2 times 16 is negative 32. And now it's super easy. Subtract, you get a 0. Alright. So the quotient is the height that we're looking for. Height is 3x squared minus 2. Alright. So that takes care of this section, dividing polynomials, section 3.5. And this is a long chapter, isn't it? Chapter 3. It just keeps going and going and going. When does it stop? I don't know. We'll find out, won't we? Now we're getting pretty close to the end of chapter 3, and then we'll be into chapter 4. Chapter 4, chapter 5, chapter 6. That would form, I would say, the heart of precalculus, and in many classes that's about all they have time to cover. But we will plug along here, so once again, pat yourself on the back for a job well done. I am patting my back. I hope I did a good job for you guys. And if you like it, please like and subscribe. I know a lot of you are moving on. When you leave precalculus, you're never going to look back. And you might not want to subscribe, but you don't ever have to look in my videos again after you've used them. You know, you can just subscribe and leave it on your subscription list and never look at it again. That helps me out, though. It helps me with the subscriptions, you know, and it would be nice to get this monetized. But anyway, I'd appreciate it if you would do that. And I will see you in chapter 3.6. Alright, so don't touch that dial, because we will be back.